This is a typical example of how differentiation is applied to a simple problem. So the question is that we're given the curve y equals x squared minus 3x, and we're being asked to find the tangent line and the normal line at the place where x is equal to 3. To do this problem we'll need to know a little bit about straight lines and gradients, but we'll get to that later. So whatever this curve looks like, we're being asked about a particular point on the curve where x equals 3. So given that x equals 3, we'll need to know what the y value is at that point, so we can figure that out immediately. So it's going to be 3 squared minus 3 times 3. So the y value in this case is going to be 0. So the point that's being discussed in the question is the point 3, 0. To find out the gradient function, we'll need to differentiate. So we differentiate y. So dy dx in this case is going to be 2x minus 3. So this expression tells us the gradient at any point on the curve. So we're being asked to consider the gradient at the point where x equals 3. So at that point we substitute into here, and we'll see that the gradient is 2 times 3 minus 3. So the gradient is equal to 3. When we're talking about straight lines and tangents and things, we use the formula y equals mx plus c, and the m part is the gradient, so it's dy dx. Okay, so what we know about this is that the gradient of the tangent at that point is y equals 3x plus c. So the only thing that we need to find out about this is the value of c. So we can use the point 3, 0 to find that out. So if we substitute these in, we'll get 0 equals 3 times 3 plus c, which means that c is equal to negative 9. Okay, so taking these together, it means that the tangent equation is y equals 3x minus 9. So there's the tangent. To find the normal, we're going to use the relationship between perpendicular lines. Okay, so if that's the tangent, the normal is perpendicular to it. So if that has a gradient of m1 and this has a gradient of m2, from coordinate geometry we know that this is true. So the gradient of the tangent in this case is 3. So it means that the gradient of the normal line, okay, so if m1 is equal to 3, it means that m2, the normal, is negative 1 over 3. As it's a straight line, we can use the straight line equation again. So it means that the normal line will have an equation which looks like 1 over 3x, and it's negative, plus a constant. Because it passes through the point x equals 3, so it's moving through this point again, passing through that point, we can use 0 as the y value, and it's going to be minus 1 over 3 multiplied by the x value plus c. So that means c is going to be equal to 1. So therefore the normal equation through that point will be y equals minus 1 over 3x plus 1.